Today's video can be found in your new 1F packet about proportional thinking. This is in Chapter 5, Section 1 of the 7th grade text in our series. It's the green one. So Chapter 5, Section 1. Alex helped out his family's business over the summer. He was hoping to earn enough money to buy a new $220 gaming system by the end of the summer. Halfway through the summer, after working for 4 weeks, he had earned $112. Alex wonders, if I continue to work and earn money at this rate, keyword there, will I have enough money to buy the gaming system by the end of the summer? To check his assumption, he decided to make a table. He entered his total money earned at the end of week 1 and his total money earned at the end of week 4, which we can see here. So if I wanted to know how much money is he doing it at the same rate, which it does say, and earn money at this rate. What is the rate? To me, it looks like it's $28 per week. Well, let's see if that is constant. If I take 112 and I divide it by 4, yes, I do get 28. So he is earning $28 per week. That's the rate. Use this rate and fill in the rest of this table. Well, I know if he hasn't started yet, he has no money. I do know that. Fill in the rest of the table. Then we don't have partners at home right now, but answer this question A and B, and then we'll go over the rest of that in class tomorrow. So pause the video and finish the table. Answer A and B. Next page. Understanding direct proportion, and we're going to look at tables. At a supermarket, each pound of strawberries costs $2. Strawberries are $2 per pound. You see these signs. They're telling you the unit cost or the unit rate. What is the rate of the cost of the strawberries? It's $2 a pound. So 2 pounds would then cost $4. 3 pounds would cost $6. The table shows why the cost dollars for X pounds of strawberries. So if you buy 1 pound of strawberries, you pay $2. 2 pounds pays $4. 3 pounds pays $6. Notice that as the cost increases, yes, it was because the weight was increasing. You were buying more. Notice what happens when you compare the cost of the strawberries to the number of pounds. The cost is the Y variable. The pounds is the X in this situation. Yes, $2 per pound. So $2 per pound means $4 for 2 pounds, $6 for 3 pounds. These are equivalent ratios because each time the first term is 2 times the second term, right? 4 times 2, right? 2 is equal to 6 times 3. 4 is to 2 as 6 is to 3. That's an equivalent ratio. These ratios can be all associated. Yes, they are equivalent. An equation that says 2 ratios are equivalent is called, that doesn't show up very well, a proportion. And we've been doing proportions, right? Is over of equals percent over 100. Next page. You can see that the cost of the strawberries is always 2 times the number of the pounds. Yes. The cost of the strawberries and the number of pounds are said to be in a direct proportion. If you let Y be the cost of the strawberries, Y is the dependent variable. And if you think of your Cartesian plane, your X, Y coordinate axis, your dependent variable always goes on the Y axis. The cost depends on how many pounds of strawberries you're going to buy. So this is the pounds, and the cost depends on the pounds. So the cost is the dollar amount, and the pounds, that's the number of strawberries that you're going to buy, right? So that's your X axis is what's called the independent variable. So cost depends on pounds. So you can write an equation to show this, that the y divided by the x always equals 2. Yes, $4 divided by 2 pounds is 2. $6 divided by 3 pounds is 2, right? We saw that in the table on the prior page. 2 pounds, right, divided by $1 gives us 2. These are all equal to the 2. And the other way we could write this is that our dependent, our cost, is equal to $2 per pound. Our pounds are our x. So y is equal to 2x. If y over x is a constant, we call it k, and y equals kx, where k is the constant value, then y is said to be directly proportional to x. The constant value k in that direct proportion is called the constant of proportionality. You're always going to get the exact same constant. Jim walks 900 meters in 5 minutes. At what rate does he walk? In 5 minutes, he can walk 900 meters. So I'm doing the unit. I'm trying to find the unit rate. 1 minute, I would take 900 and divide it by 5, right? Would give me 180 meters. So Jim walks at a rate of 180 meters per minute. That's the rate. Remember the bar modeling when we were finding 1 unit? So if Jim walks 900 meters in 5 minutes, he walks 180 meters in 1 minute. That's the symbol that goes along with that word problem, and notice they have 2 labels, meters per minute. Next page. A new self-serve frozen yogurt store opened this summer that sells yogurt at a price based on the total weight of yogurt and the toppings in each dish. Each member of Isabel's family weighed their dish, and this is what they found. So someone had a weight of 12.5 ounces for $5, 10 ounces for $4, 5 ounces for $2, and 8 ounces for $3.20. Compute the constant of proportionality. Well, the cost, if you've ever been to one of those yogurt shops, goes up the more yogurt you put in, right? So the cost, y, depends on the weight, x. So if I want to find my constant of proportionality, I've got to do y divided by x to get that k. So my dependent divided by my independent. So 5 divided by 12.5, what does that equal? Oh, it equals 4/10. 4 divided by 10, well, that's also equal to 4/10. You got to check every value on the table. Well, 2/5 I know is also 4/10, or 2 divided by 5. And $3.20 divided by 8, yes, that's going to give me 4/10. So my K is equal to 4/10, right? Meaning that I'm paying 40 cents per ounce. Write an equation in the form of y equals kx to describe this situation. Okay, well, my y, my cost, depends on 40 cents, 4/10, right, times every ounce that I buy. So y equals kx. That's the equation, right? I put my rate, my constant of proportionality, in for my k. In the back of a recipe book, a diagram provides an easy conversion to use while you cook. Compute the constant of proportionality, write an equation in the form y equals kx. Okay, so my ounces and my cups. So my ounces and my cups. 4 divided by 1/2. Well, 4 divided by 1/2, keep it, change it, flip it, is 4 times 2, which equals 8. 8 divided by 1. Well, that's 8. 12 divided by 3/2, or 12 times 2/3. 12 times 2 is 24 divided by 3, that's 8. 16 divided by 2, that's also 8. So every time I did y divided by x, and I'm getting the constant 8. So yes, what is it? K is equal to 8. Write an equation in the form of y equals kx. Well, y, it doesn't matter how many ounces I have, I'm going to take my ounces and multiply it by 8 to get my cups. Y, my ounces is equal to 8 times my cups. I think I said that backwards. My ounces is equal to 8 times, because there's 8 ounces in every cup. So if you have 3 cups, for instance, you would do 8 times 3. Yes, and you would get 24. There's my ounces is equal to 8 times my cups. That is true. The table shows the number of pitches made Y in X innings of a baseball game. So 15 pitches in 1 inning, 30 pitches in 2 innings, 50 pitches in 3 innings. Compute the constant of proportionality. I don't think there is one for this, because 15, my Y, see the Y there? So I'm doing 15 divided by 1, that's 15. 30 divided by 2, oh, that's 15. But 50 divided by 3, sorry Charlie, not 15. That's 16 2/3. So, is there a constant of proportionality? There is none. Can I write the equation then? No, because I don't have the K. So I cannot write that equation. I want to go back to the page before and relate the constant of proportionality to something that we already saw. We saw this triangle. That distance, right, was equal to speed times time. Distance divided by time gave us our speed, which is a rate when you go like 55 miles per hour, right? That's a rate of speed, a rate of speed. So we are finding a constant rate many times when we take distance and divide it by time. Y divided by x also can fit in this triangle, because y divided by x gives me my k. This is my rate. And the distance is equal to speed times time. This and distance divided by time gives me my s. That's the rate. They are related. When you have these relationships of dependent and independent variables, they usually can be fit in this very nice triangle that helps us remember that it's y divided by x gives us the k. Here's the division line here. And y is equal to k times the x. And I could even solve it for x. X is equal to y divided by the k. So just like we did here, distance is equal to speed times time, and speed is equal to distance divided by time. Time is also equal to distance divided by speed. So they are related. They are related, and I want you to add that in on that page, please. And that's it for today's video.